Hi, so my name is Pius Gumo. I am in group number 12 with Matthew January, and we will be presenting this video that will encompass basically the entire project that we engaged on in the second semester of 2021 for the EEE 3097 design course.
Okay, some background information on the Shark Boys. They are a system that's designed to monitor environmental conditions that lead to ice flows in the marginal ice zone. It's designed to be a fully automated system that can be deployed on an ice flow in various locations in the marginal ice zone. And our part in it was basically the development of a microcontroller unit, which is to be mounted on the Shark Boy, that is responsible for the collection, compression, and encryption of IMU data.
So ideally, one of the important contexts around this shark boys is that they will be used in the Atlantic Ocean. So one of the limitations that we were faced with is, as we did most of our development in Cape Town, or rather around the South Africa region, we did not have similar environmental conditions to be able to test the IMU as well as the Pi functionality. So the data that we have, or the data that we managed to test and validate with, is only accurate up until a certain point, but we do not have the full effects of how temperature shall affect this.
Some of the steps taken during the design process were developing the paper design, which was basically establishing the requirements and specifications to guide our project design goals. And we also did some basic research on compression and encryption algorithms and what algorithms are good to use, the order of implementation in our system, and we also decided on the division of work. Following this, we did the software testing and validation phase, where we basically started writing software for each subsystem and testing its functionality, testing different compression and encryption algorithms, finding out what is best. And we did this using sample data that had been previously collected and basically funneled to us. And we used this to test the functionality of what we had written. Finally, it was the hardware testing and validation phase, where we just ported the code that we had done in the software testing phase to the Raspberry Pi Zero, and we used it in conjunction with an IMU, the ICM20948, to test the acquisition of data and the functionality of our compression and encryption code that we had developed.
So with regards to how the entire system is meant to operate, initially, our initial design choice was to perform a by-the-wire type of data processing. So we would ideally be compressing and encrypting the data as soon as the data hit the Raspberry Pi device from the sensors. We gravitated away from this slowly because one of the important requirements for the entire unit was that we needed to minimize or rather reduce the cost of actually processing this data. So from the by-wire approach, we gravitated more towards a bulked approach where for the better part of the duration or session in test, we would be collecting the data and only perform this intense tasks of compression, encryption, and writing to the file at specific points. So the points we initially defined were based on elapsed time. So for example, if the value of 1 hour was chosen as the elapsed time, then the data across the hour would be collected, at which point when the 1 hour elapses, then we now move on ahead to compress, encrypt, and write this data to storage. One of the things that guided us towards this type of decision making was actually timing, or rather seeing the scalability of our code, our algorithm choices, as well as our compression algorithm choices, as well as our encryption algorithm choices. So right now I will proceed to showcase our working setup. And what I will do right now is basically just access the Pi, read some data, and you will see the action of encryption and compression taking place at each specific point. So I'll just share my screen for this. Okay, so I Sorry. Yeah, I am accessing the Pi right now. This is through SSH, and the Pi is currently on a flat surface on the table. And basically, you'll see that as we read the data. So just to explain what you're going to see on the screen right now, you will see the sensor basically reading the data for the accelerometer, gyrometer, and the magnetometer. Initially, the first reading is taken in, at which point the device tries to find out when was the last time that the data had been encrypted and stored. It doesn't find anything and then decides to now immediately start encrypting, at which point it moves on ahead to read the next 5 seconds worth of data. And once the 5 seconds has elapsed, it encrypts the data and writes it to storage again. Now, this repeats. The benefit of this software based implementation is that we can actually adapt the code to pick very different amounts of elapsed time. And this can also be changed on the fly, or it can be changed iteratively. So let us say that for a specific period of session, you want to perform the encryption and the encryption during a smaller time interval, and for another period of time during the day, you want to perform the encryption during a longer time interval. So what I'm going to do right now is basically take a hold of the Pi, and I'm going to flip it onto its horizontal axis. You can see it like this. And one thing that you'll notice, the figure that we expect to be significantly altered would be the accelerometer, which is in effect by gravity, as well as the gyroscope. And from that, you can see that we initially had the Z direction having this figure of 16752. That now changes to the X direction. That is because the Raspberry Pi is on its X axis. Now, if I take it back, you'll see that this changes back to the Z axis. Now, if I play around with the device, this was one of the limitations that we also experienced. The sensitivity that we had calibrated into our code was not effective enough in being able to actually get one constant value during a fast sampling time. So the sampling time at the moment is 1 second. And you can see that with regards to our gyroscope, we have a range of values that are coming in. The values are changing, indicating the constant change, and this is only in effect for the gyroscope as well as the accelerometer. But we would need to ideally define more calibrated sensitivity values. And that is basically the entire working of our code. Thank you.